Thank you very much for the kind introduction. Good afternoon, everybody. So right after lunch, I hope you won't be, I'll help you over the after lunch dip here. My name is Mike Müller, and I've been a Python user since 1999. So I was claim it's the last millennium, starting with 1.5. And I stepped with Python all those versions from 1 to 5 up to 3.10 and 11 soon. In my day job, I teach Python. Actually, what I'm doing right now is since I gave my first Python training in 2004, and since 2010 I do it full time with Python Academy. So if you're interested in training, you're welcome to ask me. But this is not about me, it's about you. So I would like to know a little bit about your background. So who of you knows and uses Python less than 1 year? Please raise your hand. Very few people, less than 1 year. Between 1 and 5 years? It's more majority. Between 5 and 10? Even more? More than 10? Still a few. So just numbers, the times of usage is not the main thing, but I want to get a little bit of background about your Python knowledge. Who of you has used decorators, so applying a decorator to a function? Most of the people. Who of you ever attempted or wrote an own decorator? Also a few people. So why are you here? No, okay. So we want to do a spectrum. So I gave it a bit different name. A spectrum programming is actually having cross-cutting concerns in your program. What are cross-cutting concerns? So everything has nothing to do with the business logic. So a prime example would be logging. Yeah, logging, permissions, what these functions are allowed to do, and a few other things. I have some examples, and these are cross-cutting concerns. And Python offers a tool, it's called Decorator, to solve this problem in an elegant way. This is this decorator thing. First, I would like to show you some of the basics. Then we go through some examples. So we need to cover a few things. So as all of us say, everything boils down to Python, everything is an object. So if you understand what it means that everything is an object, you also understand decorators. I also dive a little bit into functional programming, because when you write a decorator, you typically use some principles of functional programming. So Python supports multiple programming paradigms. Please download the material. This will be a PDF with the material, and if you can always read along. So I will go through the PDF. So we only have 1.5 hours, which is a bit short for the whole thing. Since I also have some exercises, and even the exercises, when you do them, you might use up 1.5 hour already for the exercises. So you have to cut this bit short. We probably do one exercise, and the other ones I leave as a homework. You will get a solution document. I haven't put it up yet, but at the end, you get a PDF with example solutions, which would be helpful. So when you unzip the file, you will get the PDF. That looks like this, plus, so the PDF will be this thing. So this is 27 pages. There's a lot of cover, so maybe like 20 pages of content. And also some files, and of course I put the files already here. So I'm going to use a Jupyter Notebook. If you know what it is, please go ahead and do it. If you want to use an editor or anything else, use whatever you like. This is not about the tool you use whatever you like. The notebook is a great tool for presentations, that's why I use it. And these are the examples here, and you can use them. So tinyurl /com PyAspect. If you come later, I will put this up back on. So basics of decorators. First, I want to start with a little bit history, because decorators became very famous with this add syntax, but actually the principle exists before. And there's a few decorators in the standard library, and I want to start with 2 of them and explain a little bit the basics about this decorator thing. So if I have a class C, yeah, I can write a normal method, and the normal method would take self as a first argument and return something. So this would be a normal method. And then Python has a notion of a static method. So a static method is nothing special. Actually in Python you wouldn't need it. You can always write a separate function. A static method, call it S method if you want, doesn't take the self, method, doesn't take the self, and here I return something like this, and here I return something also. So this wouldn't work the way it is. And in ancient times, when we didn't have this decorator syntax, you could say, now I use the same name, and I call the function static method to turn the thing into static method. So I use the same name, add method. And now I have the static method. So if I make an instance on this thing, I make an instance on this class. Now, if I use the normal, call the normal method, I can call the normal method like this. If I want to call it on the class, I do have to supply this instance as the first argument. Otherwise, I do get an exception because a method on the class is actually bound. It's bound. Yeah. So if I say c dot method, then you get a function. It's just a normal function. So everything you learn about function applies to these things. It's just normal functions. This is actually also a function, but a special kind of function. And this is called the bound method, because you don't put in the self as an argument. Python used it up already and created the bound method. Method bounding goes with descriptors, which is a totally different topic. If I had another hour to spend, I could explain to you, but it doesn't really matter. It's bound. Now, if I use this as method, it's different because I don't put the c in and it still works. Yeah? And if I say c as method, then here it gives you a function. So it didn't do the binding. So this as method is just a normal function that just happens to be the class and has no notion of the self. If you use pylint and you write a normal method and you don't use the self as in here, pylint here would complain and say, you don't use the self, please reconsider using static method. So the thing is, it's very important that this is a static method, but I'm hiding the fact here, because that's how Python works. I can only use as method after I define it, so I cannot put it in front, otherwise it complains it's not there. Yeah? So if this method is bigger, then you hide the very important fact that this is a static method after you defined it. So if I have 10 lines here until the return 43, I might not see that it's a static method because it's just out of sight. So, and then they introduced something that's called the decorator syntax. So this is just, as you might see, this is, it's a static method is a function that takes a function and returns a function. I will use the word function a lot of times in this training. So it takes a function and returns a new function. So hence the functional programming thing, because in function programming everything is a function. And now I use static method here, and this has exactly the same effect. This has exactly the same effect, and this add is just syntactic sugar to do this. And this is the main thing. If you understand that this line goes away and you just put static method in front, and now you have exactly the same effect, but it's very obvious because you put this decorator in front, you see it. And syntax highlighting makes it gives this magenta kind of color, whatever it is, that you can see that it's different. The thing is different. And that's an important message. So this is what people call syntactic sugar, but it is good sugar. That's healthy sugar. Usually sugar is not so healthy, but this is healthy sugar because it makes your program better readable. Yeah? And that's pretty much everything I need to explain to you. The rest is details, but we cover a few of the details. Because it just takes a function, it returns a new function, and we just change it. So this one worked before the syntax. I think it must have worked in Python 1, I think, because everything is an object, and functions are objects, and you can put in functions into function calls and get functions back. Yeah? If you want a fancy word, they call it higher order functions. So functions that take functions arguments and or return functions are called higher order functions. Good. This is this motivation, and there's another one. It's called the class method, which is similar. I can skip it here, doing the same thing. And the class method doesn't take the instance, but the class is the first argument. And class methods are usually used for a second constructor. So Python can only have one init, but with a from something, you might know there's a dict from keys. Yeah, you might know this one. This is some kind of a second constructor that gives you an instance of a dictionary with a different signature of the calling of this thing. Instead of init, you call the from keys method. And there's quite a few things around it. Typically starts with from. It's just a convention, but it makes sense. And I have an example here. This would be a static method. Exactly the same principle as, class method. Exactly the same principle as static method. You make it very obvious and put it in the front and don't hide it in the back. That's pretty much pretty much it about this one. So I have another example here, but since I want to go fast, a little bit faster, I skip it. You can look it up in the PDF. I'm also been around here till tomorrow, so if you want to ask me anything, you can also ask me later. Good. Real world examples of static method. I have examples in other libraries, and I found a few. You probably know more than these ones. So if you go to PDF, so click is a pretty well used arc path replacement for writing command line arguments. You use a decorator to turn a function into command line arguments. Django is using decorators a lot, like permissions, who's allowed to do something. Flask, use it for routing. You put this regular expression on top is a decorator. Python is using them. You can use Python. You can turn normal Python functions into Python functions without touching the internals. Just put the types in front. Numbers doing the same thing. So different examples: web programming, functional numerical programming, and there are other examples you might see them somewhere. And these are all cross-cutting concerns, things that don't have anything to do with your specific business logic, but something you can need in many places in your program. Good. So one more concept I would like to explain, and this is a concept of a closure. Who of you knows what a closure is? A few people. There's even a programming language called Closure. Yeah. It's a functional language that sits on top of the JVM, so it compiles a Java bytecode in the background. And obviously, it's a functional feature. And this is important to understand to see how we write decorators. There's a second way of writing decorators using a class, which I will introduce later, which is also possible. And you might argue might be even more Pythonic, but most of the examples you see with functions, that's why I would like to explain how a closure works. And this has to do with functions. So I have an outer function, and inside this function I can define an inner function. This is totally possible. And now I can do something here. So the example is not too useful in terms of what it's doing, but it should show the thing. And now I say return, and I do return my inner function. So this is a higher order function because it returns a new function. You want to get fancy, you can call it a function factory. Now I have this one, and now I can say I10, and I can use my outer to generate a new function. And if you look at this function, it looks kind of funny. It has this funny name with locals and inner and outer stuff here. Yeah, the main is just the name of the notebook, but this is a function name. And now I can call this function, and if I call it with 7, what would be the result? 17. There's only two numbers here, and I use a plus, so it shouldn't be that difficult. But this is a function. And now the question is, how does a function know that there's a 10 somewhere? Functions don't have state usually, but this is regulated via the closure. So if I have this inner thing, inner function, then I do have this two underscores. I have this closure. Why doesn't it come? Closure. No, doesn't it work? What am I doing? I10, yeah, sir. Yeah, thank you very much. So typing, talking, looking. So it's a closure, and you see that's a tuple, as you can see. One tuple has a trailing comma, which is a funny syntax in Python. So you can access the first element, and then you can go in here and you say cell content, which obviously is tab completed, and you get your 10. That's how the closure knows this value. Yeah, that's how it works internally. And then you have this nice, another word you can put up, it's called the closure, and this is a way to store state in functions. So function programming have no state. So Haskell has like everything is immutable, and there's no like a class where you modify attributes and an instance or something like this. But you can use a closure to use some kind of state in some way or the other. At least, maybe it's not the right formulation, but at least it has the same purpose in this regard. Okay, now we know what the closure is. Now we can write our own simple decorator. And at first, I just start with a normal function that it's called hello. and I just take a function and I just print hello. Print hello. So you're welcome to type along or just watch, depends how you like it. And then if I use this as a decorator, I can use my hello, add a function, and I will define this function add many times because easy enough to understand. So now you see if I do this, something strange happens. Why does it happen? So now you have to go back and do it in steps. So what happens when you put a decorator? This happens. Yeah, now you say add equals hello add. So and if you write something like this, you see now it makes sense. I'm calling this hello and put in the function. There's a small problem involved here. If I want to call my add, it doesn't work because I forgot something important. I don't return anything. And if you don't return anything, Python returns none. And you get the most famous error message. If you Google Stack Overflow, you probably find 10,000 of questions where non-type object doesn't have attribute X, Y, Z. You know, this is a typical thing. I forgot to return something because the first part of my decorator is correct. I take a function, but the second part to return a new function that replaces my function, which I do here, is missing. So I have to write a better one. Good. So write a better one. So I have a hello. That's the outer function, hello, the outer function. And I do my inner function, and you can call it whatever you like. You can call it wrapped or wrapped, not so fast, not wrapped. And then we use this thing. Anybody has an idea what these stars are? Then usually called KW arcs. So this is, maybe I go a step back later and explain actually what it is. This is a function that can process any number of positional and keyword arguments. And now I do my hello. So my printing hello here is my cross-cutting concern. I want to print this hello in many places. And then I return my function. I do return my function, and I use the same syntax here, but in a different context. You see here I define the function with a def, and here I call a function. And then the same syntax has exactly the opposite meaning. Here that means packing, and here it means unpacking. So we come to this in a second. Yeah. So, and now I do something. I return, important, I return my wrapped function. So the name of the function doesn't matter. We'll see this is not good style yet. We have to improve this one, but this is the first decorator that works. And now I can do the same thing. I'm lazy, I just copy this one. And now you see when I do this, nothing happens. In our approach before, we had some code executed at definition time. Yeah, this is something. Now this hello is executed at definition time, but it doesn't show you any print. It just replaces the add. And now if I call my add function, I do get my result. 4 plus 5 is 9. In addition, I do get my cross-cutting concern, which is printing hello. So I added something to a function with this one. It could be something more than just printing hello. So here, plug in whatever code you would like to happen for all the functions. And that's how this works. You can put a decorator in front, and it executes here. Good. Everything clear? Any questions so far? So let's have a look at this star on double star. So if I take this one out here, and we look at this, and I just print arcs, and I print this KW arcs. Yeah, so this would be my helper function, whatever the name doesn't matter here. If I call it without any arguments, see, it prints something, and it prints an empty tuple, and it prints an empty dictionary. If I call it with arguments, so I can give it positional arguments, and I can give it keyword arguments, as many as you like. Just use 3 here, but it doesn't really matter. Something like this, and give the equal. You see now, it packs all the positional arguments into a tuple and or keyword into a dictionary. And now, because if I have this, I have two containers, and I can move these containers around, and I don't care how many items I have, 0 to whatever many I like. Yeah, and you just need to know how to process a tuple in a dictionary, which you hopefully know when you work with Python. So this is the first one, and now I can do the same thing. I can, or the opposite thing better, I can now call this function. This one hands over the argument. So if I call my function add in the common way, I do get a 5. If I have this args in a tuple, yeah, and I try to call my add, it's not going to work. Yeah, but if I use a asterisk here, I unpack this tuple into two arguments, and this will be equivalent. So doing this call is equivalent to doing this call when args contains these two numbers. And the same holds true for this double asterisk thing. It unpacks the dictionary as keyword arguments. Therefore, this function can replace any other function in terms of its signature. This is very important. It's very, very generic. You won't get any more generic than this. You can call any function with it. If it makes sense later, it's not guaranteed, but you will survive this line here because the function will be called. If you get an exception, it will be inside somewhere if you do something wrong. So this is the usual way. In this case, I just move the arguments from here to there. You can also do something with the arguments. You can inspect them. We have an example to doing this. You could modify them. Yeah, so you can modify a tuple, but you could make a new tuple, which is longer or shorter, or take something out. You can modify the dictionary. So everything's up to you. So in Python, you can do a lot of things. As we've seen yesterday, lower item talks, you shouldn't replace 18 with 0, but you can if you like to. Yeah? So nobody stops you. If you feel like that's a good idea, go ahead. The recommendations are not so. Good. This would be a simple decorator here. This decorator has a small problem. Now, make it a bit nicer. And add a docstring to our function. Add two objects. Yeah, so we can add any objects that work with a plus. That's fine. So it still works. Yeah, but if I look at the docstring, which I can do here with a question mark in my notebook, then it says me there's no docstring. And if I look at the name of this function, see now, not hello, whatever, add, sorry. That's what I meant, add. No, still no docstring. And if you look at the name, add this add, now it looks like this. I would like to have the name add and not this strange local wrapped kind of business here. So this is not a good way of doing it. You need to make it better, and for this you need wrapped from functools. So the standard library provides the functools module, and I import a helper which is wraps. So it's not the leftover from the lunch here. It's not nothing to eat, but we can use this. No, we can use it here, and I just go up here and take my hello, which is missing all the docstrings, which in the PDF I do have docstrings, but I think we don't need to write them here. And now I just put it here, and now I use this one, and this is finally also used as a decorator. So we use a decorator to make a decorator better, and we wrap this function, and I have to say which function I wrap. I say func. And because it doesn't assume that the first argument is func or anything like this. You have to put it in. And if I do this one, now I can decorate my add again, which I do here. Yeah. And now if I look at my add and my docstring, the docstring is there, and if I look at the representation, looks nice. Yeah, the wraps, you can look at the source code. The wraps is doing nothing else, just going through some of the attributes of the original function and adding it to the new function. It's still a different object. If you look at the ID, it's different than the original add I defined. Yeah, I won't be able to access ID because we replaced the name here, but it's actually a new object, but it looks exactly like the old object. And that's a basic principle of Python. Python usually doesn't care for the object or the type, it just cares for the behavior most of the time. As long as the object is doing what you want, it's fine, and you don't care what it is. Yeah? And this is just this principle here, and you just use a different function, but I don't care. It's doing exactly what I want. And if it's function 1 or function 2, who cares, as long as it works and the result is correct, that's fine. Good. So always use reps to make it a nice function to keep the doc string and do something like this. One more thing, if you write a recursive function, then this wrapping will also influence any other recursive function call. So recursion is not a good tool in Python most of the time, because there's like, now the standard recursion limit is 3000. So you should use recursion only if it really is a key kind of a problem that's really recursive from nature. And don't overdo it, because if you reach like 15,000 recursions, the program just dies without anything. There's not even an exception, nothing. So it depends on your operating system version, but between 10 and 20,000 somewhere are just going to die anyway. So recursion is not the technique that you should use excessively in Python. It's slow, resource hungry, and so that's the thing anyway. So I rarely use recursion. If you have a problem where something is referencing itself, and then maybe recursion is okay to solve it. But if you can turn it into iteration, it's usually much easier anyway. Yeah, so iteration is usually easier. And very often you can, with Python, iterate or something, turn it. So just small thing that recursion will also be influenced. This is the basics of decorators. Now I have a few use cases to show you what's going on as an example. And you will see that will be the same thing again and again and again, just with different use cases. The first one would be caching. So I do have all my examples here, and I can load them directly here. And I call it cached because I think there's a name clash with some other thing called caching, so I call the thing cached. And this is one example, cross-cutting concern caching. So if you have a function that is called often and very often produce exactly the same result. You need a deterministic function. So if you call this function with the same arguments, it always gives you the same result. If you have a function that includes time, the caching doesn't work, because that would be still yesterday if I called it. So it doesn't work. You have to have a deterministic function. And this is a very, very simple. Don't use it as in production. There are much better ones, but it's good enough to explain the principle. And very often for cache, you use a dictionary, and that's what I'm doing. I put a dictionary inside the function, which makes it not very useful because it's really hard to get to it. You can still get to it, but you need the introspection stuff. So this is a cache that cannot be invalidated and cleaned and anything easily. But it still works. You see I have this outer function and the inner function. This is a typical naming thing. You call this cached, and the nested function use underscore cached. This name doesn't matter anyway, but this will go away. This name will disappear. Yeah, this is wrapping thing, which I do here, this functional wraps, and will go away. Therefore, typically you don't have to invent a name, you just can use an underscore, and we'll see there's even a version with 2 underscores, leading underscores. Yeah, so, and then I need to create some kind of unique key for my dictionary that saves the arguments, and that many different ways. I use here pickle, which kind of restricts my function. So if this function would take a open file object, pickle wouldn't work. Yeah? Pickle is Python's serialization module, and you can pickle most Python objects, but you cannot pickle file handles and sockets and these kind of things. That wouldn't work for this, but I assume it's not the case. So if you want to hide the real one, you have a bit more effort in this generation of this key. But there are a lot of solutions out there. So that's not about this specific usefulness, it's just more the example how the decorator works. And I create this key, and then if key is not in cache, I call the function and store the result, the return value of the function, in the dictionary with the key. If it's there already, I just return it from here. So I don't recalculate the thing. Yeah. And that's all. This one is not very, so if you have a function, the same arguments comes as positional, and as keyword, it will be a different function call. But we assume you don't have so many combinations, and make it easy, you might have some additional function call. And now if I do this, I use my cached decorator here, cached decorator at my grade function add, which we're going to define many times here, and I just add a print to see that something like happens. yeah, and return my a plus b. So, and now if I call my function add with a 2 and a 3, you see the first time add prints called, the next time it doesn't print called because it just reuses the value in the dictionary. So there's no easy way to access this cache. There's many different other ways. You could add it to an attribute to the original function and then make it accessible from outside. So you might know at least recently used cache, LRU cache in Python, is doing exactly this. It's a decorator, and they add attributes to the original function, and with these attributes you can clear the cache, you can access cache statistics and all kind of stuff. This is not nearly as fancy, but it's the same principle. The same principle, and now you know how to write a cache. So if I do this and I call this with a B here, which is exactly the same, but my algorithm is not smart enough to figure this out, this would be a new signature and it recalculates everything. Yeah. So if you want to do this, probably it's possible. We need to inspect the output and do some fancy stuff with it. But this cache doesn't make sense anyway because my a plus b is much faster than this cache thing. So this makes everything slower in this case. That's not the case. You have to have a function that's somewhat expensive to make the cache useful. Adding two numbers is not expensive enough because generating the pickle and the dictionary and all the stuff costs more time than this one. Good. But as an example, caching is a very typical cross-cutting concern, and we solved this problem here. The next one I have would be logging. And again, I call it logged to not conflict with the Python logging sound thing. But here I give it a little bit a different thing. So I use a constant, which I'm going to change. It's not a very good constant, but just an example. So this would be in a real, the notebook is different from a real program. See, I can rerun the same program again and again with the same class definition, which you wouldn't do in a real program. But for learning experience, it's kind of okay. Yeah. The notebook's very different from it than from a real program, but I'm doing here. So I have this global constant logging, which is set to false. And this is exactly the same thing as we've seen before. I have my outer function that takes a function. I have my inner function underscore logged, which has a reps in front. I have my arg stuff. And now this is different. I have this global thing, logging. And if logging is true, I do some printing. So here I should do some proper logging. Here I just print logged. So there's no logging whatsoever. It's just an example that logging could be there. Now if I do this, and I add my decorator, if I manage to type the right thing here, add my decorator logged to my function. Okay, and if I call my function now, nothing happens because this log is false if I set it to true. And I do the same thing again. Then you see now it will be logging, will go on. So now I have a global switch, which in this case I can change the switch at the runtime. If you want to do this a different thing, I could, but you don't have to. You can set it once, and then all the loggings will be on and all the loggings will be off. So you only have to sprinkle 150 ifs in your code. This would be one if, and you just put the decorator and can turn everything off. Here, I can change it at runtime. You could even go a step further and just say if logging is off, I return the original function without any changes. And if logging is on, I return the modified function. That would be no extra overhead. Here, I always have an extra function called overhead. If this is a problem or not depends. If this function is running for half a second, then this extra overhead of another function call doesn't make sense. If the function doesn't do anything like here, a plus b, the extra function overhead was a plus b is very fast compared to the function overhead usually, more or less. Yeah? So this would make it nearly twice as slow in this case without doing anything. So instead, you could just return the function unchanged if logging is off, otherwise there. Then you can change logging at runtime to change the behavior. You have to change it before. That would be a variation of it. Everybody with me what I'm saying? Not too abstract. So always, if you have anything, raise your hand. You can always ask questions. Yeah, so it's good to have feedback. Yeah?
I have a question. Can I inform the decorator what should be printed if I want to decorate different functions, I want different things to be printed, let's say.
Yeah, the question if I can inform iterator what to be printed, yes, that's our next topic, which is called parameterized decorators. You can add yet another layer, so 3 devs, and then you can inform the decorator and give it, instead of just print logged, you can, for instance, hand in the text that's to be printed, for instance. Yeah, that's our next topic. I moved a little bit back. It's called parameterized decorators, which you can write with yet make another level indentation, or alternatively, I also show you how to use classes, which saves you a level of indentation. Yeah, maybe easy to understand, because every level indentation makes it somehow more difficult to follow what's actually going on there. Good. Yeah?
How would you return the original function?
Yeah, how would you return the original function? Let's try to do this. So I call it log2. Yeah, so you say, okay, now instead you say if logging, you take this out. If logging, you put this here, and then indent the whole thing. So if logging, you do this, and I have to indent this one here, and then return logged. Yeah, and this one has to be indented. Otherwise, I don't even need an else here, I guess, because I have the return is there, so I can just say return the function unchanged. So hopefully it's okay, yeah. So unless you just type like something like this. And now, if it's false, then now if I do the same thing up here with log2, just do this with log2, then the function is just unchanged. I return the original function. And if I say logging to true, now it doesn't change anymore. I hope I'm correct. And I do the same thing. No logging, yeah? Because now this logging was used only here and it's never touched anymore. So now I return the unchanged function, no zero overhead. The only overhead is when I define the function, but this is nothing. It's just once when I write the code. You won't be able to measure, I guess. Yeah. And if I set logging to true, so copy the whole thing again to stay with the flow, set it to true, then it's on, and you cannot turn it off anymore. So if I set it to true here, of course now I will return the changed function. I call it log3. Just to, yeah, let's get a little bit hairy now. It's just changing all those names, but hopefully this makes a point. Say log3, and I now call my function at logging is on, and I cannot turn it off. If I set it to false, it doesn't go off because I just have the function which doesn't do anything. This would be setting at define time, so you cannot change at runtime. The other one adds overhead, but you can turn it on or off at runtime if you want to do this. Yeah, so here you have to restart the whole thing, unless you kind of go through and do some name. I don't know if you probably could write a solution that's replacing the function, but it's not good style. It would be very indirect, very difficult to follow. Yeah, so in Python you can do pretty much anything any way you like, but it's not a good style and it's not the recommended way, when you should always go the recommended way. But here you can return the original function without changing it. It should be zero overhead if you don't count the compilation, but the compilation to bytecode is just nothing. Yeah? Good. Any more questions? I do have a short exercise, and as maybe we spent a few minutes, so you can write your own decorator, and the example is timing. So if you go to the PDF, you will find an exercise as a write a function that uses default. There's different ways of timing. So if you know notebooks, if you don't have to do this, you could use time it, which is IPython magic, time it. And IPython magic that is doing all the heavy lifting and is much more comfortable, but I show here. But you would need to have IPython installed and use a magic. You can use a magic in normal script. There's some get IPython magic stuff. Yeah? And this one here gives you this one. So this it's twice as slow because it's an M1 machine, but I still the old Python. I don't have the ARM Python yet because I haven't upgraded yet. I figured out how to ask the folks from Counterforge how to do it. So it's 8 nanoseconds, used to be 4, with M1 is twice as fast. So this would be easy, but we say from timeit, which is this Python standard library module with the same name. Timeit actually is using this in the background, the %timeit, import default timer, and with the default timer, which is actually just the alias for timeit timestamp, some other function we will see, you get a timestamp. So if I call this default timer, I do get a timestamp, and this can be a different number depending on your operating system, but we're usually not interested in the absolute value. We just want to have the difference. So I have a start value, and then I do this, and then I have this one and subtract the start, or give it a name end if you like, and it tells you how long it took. It took me 7.5 seconds to do this. Yeah, so see how fast I can type. Yeah, that's about as fast as it can go. If you put everything in 1, this should be more or less 0, but you will see it's not 0. This is my measuring error. This is not correct, and you see now it's a thousandth of a second. It's quite a bit. So this is your overhead. So you cannot measure things at a faster approach. Would be to repeat it many times and divide it. Actually, timeit is doing exactly this, and that's why you get this one is doing this new one. They have now 1,000 separator, much easier, 100 million. Otherwise, I was struggling to read it. That's very new, so it's good to always install the newest version. Now we have 1,000 separator. You do it 100 million times, so one run takes about 1 second, more or less, and then they repeat the whole process 7 times, so it can give you a mean and the standard deviation. And if the standard deviation is small versus the mean, then it's kind of accurate. If the standard deviation is big, it seems like we have big difference between measurements, which is the indicator there are some caching effects or something is wrong. What? I don't know, but something is not really good. So this is much better, and you will see I won't be able to reproduce this number with my timeit thing, even if I do something. To my experience, always twice as slow or something with my measurement. So when you measure something, very rarely everything is totally correct, but typically you just want to compare things. And if you makes the same measurement error with 2 things, and the error is always the same, then you can still compare things, even though the precise number is not correct, because this is twice as fast as the other one. This is kind of okay. So you always have to take it with a grain of salt and don't look at 1 or 2%, which can be easily a measurement error. Yeah. Good. So use this one and write a decorator. Just take advantage of my examples. Write a decorator that's using this start and end to get a timing and apply it. That would be an exercise. So maybe you spend a few minutes. You can try. If you have questions, feel free to ask me. I'll come around. For the people in the room, the people that are not here, it's a little difficult. But you can still ask questions, and I will give hints and then in front of everybody. So please try to do something. So you just need to have a Python 3.7 to 3.10. It doesn't really matter. It would involve 3.6. There won't be any big difference here. And you can use any kind of tool we prefer.
Folks can also write on Slido.
Yeah.
If they have questions, and I'll ask them to you. But that I'm done currently.
You are welcome to discuss, of course, to work together, so it's no problem. I'm not sure how the online people can collaborate, but you can also, if you have a means, I'm not sure. When you have anything, then ask me. Yeah.
I'm not sure which one should we do now.
Yeah, this is an exercise, so this was a question which one to do, so that's a good question. Yeah. So if you go here and you have this the first exercises session, this would be this one. Here, this 2.8. Kind of a little bit shifted somehow. Yeah, this 2.8. on page 11, so the printed page 11 on PDF page 17. So use a time default timer to do this, and also next one reps. If you can do everything at once, so wrap it on in one, wrap it up in one. Go. Yeah. I can hear. Can you say?
Can we try to combine cached and log time to see if using cached improves the time?
Yeah, you can. Yeah, of course. And then, yeah, you can do this. So you can apply your decorator to your decorator function to check if the decorator works correctly.
For a second, I tried with
So I have log time.
Mm-hmm.
And I try to apply cache.
Yeah. What's rest? Can you go up? Yeah, that looks good. Yeah, that's okay. And what does it say? Yeah, it won't get any faster. You have put a sleep in there just to make the effect. I guess to see something, just put a sleep a second, then you should see something. There should be a difference.
the first one should take the longest.
Yeah, so if you like put import time, sleep a second, then you should see the first one should take about a second, the other one should be much faster. Yeah, this is, you have to make it easier to see the difference, because if difference is so tiny, it's very hard to see if the difference. Yeah. Good. So I see it. First people are finished. So who finished number one? A few people. Number two is very easy, so that should be very difficult. Good. So since we have a few things to cover, I showed the solution. So of course I prepared the solution. That's why I turned it off. So I have solution, and I have this exercise one solution. It could look something like this. So I have I improved the road a bit differently, but it's fine. So I have my func tools, my time, and my time it. And you see I have this this measure time function, which takes a function. I have my reps, and here I call the proxy function, whatever you want to call it, doesn't really matter. And then I have my start and my end, and here I do my function call. I save my result, and then here what I'm doing is just put it together and store it in a dictionary. So instead of printing it, I store all the runtime in the dictionary with a function name. And you call the function the second time, will override it. It's not perfect, but it's totally fine. Yeah. So and that's what you can do. And then I have I just use my decorator and put it onto functions and call it. Actually, I could actually load this one here, which makes things easier. Load solutions exercise 1, yeah, and this would load it in here, and I can execute it the same thing, yeah, and can execute it with measure time, and that's what I did. I use my time sleep to make the point. And now if I run this one, it takes a bit, and I get a dictionary with the entries of the functions, and this is a function without the sleep. It's a -6, yeah. And the function with the sleep is 1. You see, this is much bigger than this, so sleep is not exactly 1 second, it's approximately 1 second. And be careful, especially in Windows, very coarse. If you call sleep a million times with the millionth of a second, you end up with like 10 seconds and not with 1 second. Yeah? It's not very correct. It's approximately a second. Be careful. But it's good enough to make my point. When I put in sleep, how long it takes, I have my time, and you have different timings, and you have these measurements. So this is always the same principle. Whatever you do, logging, caching, time measurement, anything, same principle. You can use it as a blueprint and just need to change your business logic or whatever you want to do. Good. And of course, I use the reps immediately, so this includes number 2. You always should do this. It's just as a reminder. So let's continue. We want to get a bit more advanced. There was a question already how to make this decorator a bit more general, and for this one I can now, instead of say hello, I use a say, and now this function takes a text I would like to display. Then I have another level, and now I'm on my function level. So this outer level I add, and then I have another one. This, let's say, 3 underscores. Different ways of the names are totally free to use, but this pattern people do. And here I use my standard args KW args thing. Yeah, this would be this. Now I print my text instead of hello. And then I do this return business. So if you have 3 defs, you have 3 returns, very easy. And sometimes if you have a function that doesn't return anything, you could skip it. But in general, the number of defs and the number of returns should match. And then I return. And now I return this underscore, say. It's not a dunder, it's not leading trading, it's just leading. And I return the underscore, say. So now I have 3 returns and 3 defs, so it should be fine. You see the returns has to be one level more indented. And now I can say my function, I use my say decorator, and now I put in my hello, and I define my function. And now if I call my function, it should also say hello. Yeah. And now, of course, now I'm free to change the text. And this is called a parameterized decorator because the text is a parameter, and I don't have to hardwire any text. And for any text, every other text, I have to write a new function. I can use one, and the outer one is putting a text. Now you can, if you want to unroll this in one line, it takes a little bit. So but first you can write the function, and then you can say add equals. Yeah, you see now I have this function which returns a new function that in turn calls my add function. I hope this is correct. And something is wrong, and I don't have to put this syntax there. So, and if I call my add, hopefully this works. And this works. Yeah. So that's what happens. So this one, the first one returns a function, consumes the text, and this returns another function. So this is a little bit. So putting this add there is easier to understand, I guess. Yeah. But that's what happens in the background. And now, if you have this, you can chain these things. Now I can use one in the exercise. He did it already. So you can use another one, and I can say now, say again, and I can say goodbye. Yeah. And now goodbye. Say goodbye, and if I add my numbers, and now it says hello, goodbye. So you can put as many decorators at a function as you like. So you can never assume you're the only decorator. You never know what people do with your decorator. That's why always assume you're not the only one. There can be other decorators. Yeah? Always assume your decorator's not the only one, there can be others. You might have seen it, some Django is using very often multiple decorators on top of each other. And then the saying goes, if you use more than 5, it's a general because it's so highly decorated. You know, so that's what I learned it from somebody else. It's not my invention. But that's what people say. You can do it. You shouldn't overdo it because decorators. It's not really clear what's happening. Maybe. Yeah. So far we used functions to create decorators, but Python actually doesn't care for function. Python cares for callable. What's a callable? Yeah, int is a callable, but int is not a function. So if you look at the type of int, then you see int is actually a class. A type is a class. So you can call functions are callables. So instantiating, creating the instance, and calling functions the same syntax. If you use language like Java, you need different syntax. You have to write a new there to make an instance. Here, you don't do anything like this. So you actually don't care. So when I do my introductory courses, I say I call the function int. That's a lie. It's not correct, but it's good enough because people have no idea what the class is. But you don't need to know because this instantiation is exactly the same, looks exactly the same as calling a function. And that makes a lot of things possible. And you have a concept of a callable. So you say callable, and if I say callable int, and that's all I need to care. And I don't need to care if it's a function or an instance or something else, as long as it's callable. If I define a class A, and I don't do anything, and I make an instance of this class, and I say it is callable, then it says no. But I can make my class callable. I can make a class, and I have an example here. Let's say a counter. And I can do something like this. We don't have to do this with the init, but to make my point, to make it a bit more flexible. So I have an init, and I have a function, and I can store. No, I don't have a function. The function is other place. So different example. You could put this function from outside, and I say it's self count is 0, and then I make this thing callable by adding a special method which is called call, dunder call, yeah. And I don't take anything here as an argument. I just increment the count. So it's not very useful, but makes a point, plus equal 1. And now I can make an instance of my counter. Yeah. And if I say now, is it callable? Callable. That tells me it's true. Because when you call a function, if I call my function A, B, 4 and 5, 3 and 4, yeah, then actually what Python does, Python just say, give me this call, yeah, and it just calls this one. Exactly the same. So you don't have to do this, the function is doing this, but then you use the parentheses, Python is using this special method call. That's operator overloading, and this is a nice thing because now our instance is callable. And if I call, now I can look at my instance, it's 0, and if I call my instance and I look at the counter again, then you see the counter went up 1 and so on. So every time, now we have a function with a state. It's not a function, it's the instance of a class, and now we have a state. So that's what I recommend. You could add attributes to a real function, but maybe using this approach is cleaner because when you have an instance, you expect that you change self something. A function should be preferably what's called a pure function, so a function doesn't change anything from outside. Yeah? So Python doesn't have a really pure function because you can always impurify it if you like, but you could strive to write something that's as close to the pure function as possible. Therefore, when you change something, I would always recommend use a class. When you say class are assigned, that instances change attributes, function are assigned to don't change the outside world. Yeah? So now we have a callable, and now we can rewrite our say here as a class. Say. So usually you capitalize the class, but it would be the same thing. In this case, you might even consider using lowercase for a class. Yeah? But let's go with to see the difference. So we have an init, as always, and I do have my text, which I store here, and this now takes away a level of indentation. And this is, yeah, so if you run this to Python with Macape, then taking away level and indentation reduces your complexity, so you get a better score. So if you're running for score, that would be one way improving your score. But still, it might also make it better readable because I do something like this, which you always do, and I define my call, and I do all my business with the printing right here, self, and I put a function, yeah, and now I should be able to actually do all this say thing from in here. So if I go here, this should be exactly the same. Now I should be able to use this one, and then you might not want to, you can call it say, so whatever. So this should be okay. I recall, it should be fine if I'm not mistaken. And of course, it says self-text here. Self-text, that's the only difference. Yeah. And now I have this one, and I have a problem indentation problem. Yeah, inconsistent indentation, a copy-paste problem. And now I can use my capitalized, say, to show the difference. Say, hello, to my function. 4,5. No, 4, A, B. So, did so many times. I should get it. And hopefully now this does the trick. Yeah. Now it's the same thing. And now you see we have and this is pretty easy because you only have one function you return. You don't have this def. You only have this def in here, and you have normal methods from classes you know anyway. So there's not much new here. Same thing. And maybe better. Most of the time you see examples with this nested functions, but it's the same thing because Python just wants a callable, and it doesn't matter how you create the callable. So if you feel like you can also fiddle around with lambda, which is really not easy, of course lambda also creates functions if you want to do, but usually using a def with a doc string is much nicer than doing something with lambda, especially if you want to reuse things. Yeah, so this is a concept, a different concept, Python's operator overloading. The parentheses, if you want to call them operators, or operator overloading, you can also overload built-in functions like lang or so, the same principle. And now you can use a class and the instance to do this here. Good. Any questions about this class thing? Anybody totally new to this standard concept? This is two leading and trailing underscores. Yeah, so if you see init is a special one because this one, when I make an instance at this place, the init is called. The init is just a special method which is used a lot. And this syntax with this true leading and trailing underscore is reserved for Python internals. Yeah, there's a question?
I guess this could also help us with our previous problem where it would be evaluated, the function would be evaluated at definition time, and here we could modify the say object later on.
Yeah.
Or would that not work?
There was a question about this definition time and call time. This would be exactly the same. You can apply exactly the same here. So it depends when you want to do it. So, I would need to try out myself and have different ones, but these methods, everything will be defined, but they won't be called yet at the time. You will see this. You can import it, but when you call the function, you get a name error. This is not there because Python doesn't check it only when you execute. But the definitions will be done already. It's the same thing because a class doesn't have a namespace. Class has no own namespace. You know, if you have this local global built-in, there's no class in there. Yeah, so it's not different, I think. Yeah. But we can try this out and see what impact it has. But it should be the same. So let's look at some examples. I have some more examples, which now use parameterized decorators. And this is called argcheck. So now you have type hints and everything, but you can still use a decorator to check types of your function. You could extend it, not only checking types, but checking values that are between 0 and 100, whatever you like to do is totally up to you. Here I restrict myself to positional arguments. So now I have this back to my 3-level approach. And the outer level takes an unspecified number of argument types, I will explain in a second. Then we have this check function, which takes a function, and then we have the wrap function that's actually doing the work. And see, we restrict this other to just args, no keyword args here. Would make everything more complex. It's possible, but I just left it out to make it easy. So I have two checks. The first one is the number of args in arg types has to be the same. If not, I give out an exception. Yeah, so could use f strings here, but it's fine. Still the old way of doing it. Maybe just make a message and raise a tape error, and then you go through in lockstep between args and arg types with zip, and arg always needs to be an instance of the arg type. So this is like int, and this would be a number 1, and you check number 1 is type of int, everything's fine. If this is a number 1 and this is a float, then you might get an exception. So or it's a string, there's some other type, then you get an exception, it's not the instance. Yeah. And I just give out an error message, would just say, okay, I expected this type, but I got this type. So you could get more fancy there, that's fine. And then I do my function call, And my return, 3 defs, 3 returns. Here I restrict myself to position arguments. So this add before, you can call this anything that works with plus. You can also work with strings. If I now use my argcheck decorator, which I need to, I think, execute first before I can use here. No, what's the name? Checked. It's called checked. Yeah. Check. So if I define my function, and here I have to actually, I forgot something. I have to give it say I want only allow 2 ints, and then I can only use ints. Yeah, and now if I use my function with ints, everything is fine. If I use something that's not an int, then it complains a type error because expected int but got int float. Yeah, so that's something you can do, and of course you're not restricted onto types. You can do any kind of check, because it can only be positive numbers, or can only be dates that are not in the past, or whatever you want to do. Yeah, so you have to just improve your checks there, and you can restrict something. Yeah. Yeah. Question?
So this new function where you can indicate the type of Python of function arguments is done something the same, or like, there is the same. So for example, like def add for like, and you define arguments, name of arguments with the types directly.
There was a question about the argument types, but I didn't understand the question.
Yeah, so for example, you can also write when you define the function, you can also write the functional type of arguments directly in the function description.
Yeah, this would be type hints, but they wouldn't be enforced at runtime unless you use a special library. This would be a new way of doing it. Here I have a decorator, and it has nothing to do with type hints. So type hints are just type hints, which usually are only used at development time to give you an error message. Python, the vanilla Python interpreter still runs, even if it's totally wrong. It doesn't do anything about it. And here, you enforce it at runtime. So there's a different concept. You could also try to fiddle in type hints and inspect the type hints, and then use the type hints with the decorator and do it with the type hints as possible. Here, put it explicitly in front. This would work with Python too, no problem. Yeah, so. For instance, you don't need type hints for this. It's just an example, and you could use a decorator that's going in and expect the type hints and does something with the type hints. I think there's tools out there that do exactly this. Yeah, here's just an example of what you can do, and it's not production code. If you want to have something a bit more sophisticated in doing something, yeah, but it's up to you. You can always use this type hinting stuff. Good. There's one example: argument checking. Now, let's go and do a little bit different example. This is called registering. So I can register something. And it can be interesting. So we didn't have this before. I have a registry. Yeah, so if you work on Windows, you might know the registry. And this is just a dictionary in this case, just some place where you put something in here in the global namespace. There could be other namespaces. And I have 2 versions. I have a register at call, and I do have a register at def. So this at def is a bit different. And let's try this first and then look how this works. So first, if I look at my registry, it's an empty dictionary, nothing there. So if I say add register at call, and I can also give it a, say this is simple, give it some kind of string, some category or something, and I have my great add function. So if I do this, and I look at my registry again, then you will see it's still empty, but if I call my function, then my registry will change and will now have something that has a list. Just the function will be added to a list. I don't know if it's useful, but it's just something happens. See, and if I call this again, this list will get bigger and bigger. So the arguments don't matter here. And if I do this and do this again, then you see my list gets longer and longer with the same function in this case, because they're all registered simple. So what I did here, I just used this global dictionary, which could be also improved if you want. You can put in the class, modify all the things. And now I have my dev approach, you know already. This is the name, my simple. And I just say, I use the set default here, so I don't have to check if it's empty. I make a new one, otherwise I append. So that's just a typical use of set default. So dictionary method. And then I just put this in here. I put append the function, and I just return this one. That's everything the same, only this is different. And this happens at call time. Every time I call, something changes. Okay, so you can also, now my registry, it's a dictionary, and I just can use clear to empty this thing. Now my registry is clear. So now I use what's the name? Forgotten. Register. Register at definition time. Register at def, and at the 20th time I define my function here. And now, if I look at my registry, you see my registry didn't change. I need to call my no. I didn't execute it. No, I executed. What happened? Why did I accept? I need to parameterize it, sir. Thank you very much. Yeah. So I have the complex. So I have to use it in the right way, and if you do it correctly, it works. You see now. This is different. We didn't have, most of the time you change the runtime behavior of a function, but you can also do something when somebody defines a function. That's possible. Now we have my registration, and you have this. And if I call my function, nothing changes. I can call my function, and this doesn't change the registry at all. Nothing happens anymore. I'm too late. Yeah. So now that's different. You see, I've lost the level of indentation, because I just do this here, and I return the function unchanged. We did this before with another example. I just return the function unchanged, do nothing with the function, and just do some side effect. In this case, I register somewhere. That's not as common, but it's possible. And you could write your own plugin system if you want. So the user writes a function, and they don't have to put it in some directory, import it. It's just decorated, and when you decorate, I have it. I can do something with it. Yeah, that would be one way to do some kind of plugin style kind of thing, if you want to call it, whatever you want to call it. But this would be a way to register a function to somewhere. Yeah, good. Okay, let's continue. We only have 15 minutes. So this is my registry example. The next thing is class decorators. So far we decorated the functions, and it's been around for a long time. Class decorators are newer, and they are nice because class decorators can solve quite a few problems that you, before the time you had to go and write a metaclass, which is something take another 2 hours, the metaclasses. Fortunately, nowadays, metaclasses are not really necessary anymore. Python 3.8, so got some new things. So you don't actually, the usage of metaclasses is much, much less than it used to be. And class decorators are nice. They can be used instead of for things you did with metaclasses. And they're actually easier. They're easier than function decorators because there's no nesting. I just get a class. I write a function that the class and returns a class. And in between, you can do something. And here, you could just access attributes. You could also add something. That's possible. Something like this. And now, I use this thing and mark my class. And the class doesn't do anything, so the class should be empty. And if I make instance of my, actually, I can just look at the class. It's a class attribute, and I see the new is there. And you don't see when you define the class, you don't see it as a new. And because I just get the class, yeah, which is A in this case, and I just add this attribute here, and then I get it back. So this is something that would be, you can modify it, but you can also just access it. Yeah, so, and a class has a dictionary, and you can access a dict. Yeah? You might know this one, dict. So this is something you shouldn't really program with, but inspect me is fine. And then you could see all the attributes in here, which are the methods and other things, and you can inspect and do something. And you can, if you don't like it, you say, okay, I don't like this class, don't do it, and just raise an exception and stop the whole thing. Yeah? The class decorators are easier, and they're very powerful because you can do a few things. There's one thing is they wouldn't work with inheritance, so they don't get inherited. You have to edit every class. Whereas if you fill around with metaclasses, then inheritance actually is the one way to use it anyways, because usually you want to hide the metaclass on the user, so you make a class people inherit from, and then it would work with inheritance. So that's some small problem. There's another solution to this, but very often you don't need to consider inheritance. So there's another example use case. A use case would be, for instance, assert something, assert fluid. It's my use case here. So I get my class, and I just say, okay, if I say assert that the class dot temperature is between 0 and 0 and 0. Less equals 0, and write a 0, and write a 1, and 100. So this is, anybody as a physicist, we don't consider air pressure on anything. It's 0 and 100. So just no salt content of the water, nothing. So that could change this one. And don't forget the return, otherwise it's going to work. And now I can say, okay, I have my assert fluid, and I say, okay, this is a class water, and I have a temperature. So when I just copy this here so I don't mistype temperature, 10 minutes left. Oh, yeah. So assert times 10 minutes. No, temperature, and say 25. Everybody's in Celsius here, no Fahrenheit. Great. Okay, then it works. Yeah. If I do the same thing, and we say ice, and I say minus 25, then it's not going to work, hopefully, and I do get an exception at definition time. So I cannot even define my class. I do get an exception, and usually you get a problem when you instantiate class, you call a method, get a problem. Here I cannot do this because I do assert fluid. So be aware, assert can be turned off. When you start Python with minus this dash C for dash O for optimization, then asserts will be turned off. But for this purpose, it's okay. And then I get this exception here. The same thing if you go over 100 degrees Celsius, so we assume Celsius here, then you get an exception. This would be a verification here. So I have this locked, cached, registering. Good. I have another example in my PDF, and I don't have the source code here. Problem. Okay, let's just quickly look in the PDF then. I will upload the source code. I'm not sure why the source code is not here. Okay, so there's another example here. We can have a quick look at time. So this one, I'm somehow missing the source code, but just have a look at it. So this is a little bit more involved, but you can do this. So now I say, okay, I would like to check, allow method names that are that only the maximum length of 30 or whatever I want to give. So I write this, the thing def. You see, I specify the maximum length of 30. I take the class name in. I go through the dictionary items. I get the name of the object. If it's callable and if the length is more than whatever I specify as max length, I don't like it. I generate an exception and raise a name error with this exception method here, and then I return the class and do this. I don't know why the source code is not there. We would have some inclusion problem, but it's in here. And then if you use it here and you define a method that's a little bit too long, here, then it throws an exception because the only thing I inspect the dict, and I can do this addict. This would be have been a typical example for a metaclass, yeah. But you don't in a metaclass use a decorator, and the only logic goes in here, inspecting this dictionary and do, if you don't like something, in this case the name is too long, you just show an exception, you stop the whole thing. So you can write a lot of these tools that do all kind of things. Instead of the length, you could also check if it's the naming convention, if it's snake case or not snake case, whatever. No? So some like regular expressions and they are do whatever you like. That's totally possible and can be done with a class decorator. Good. This is a thing. Then we have exercises, but we are pretty much out of time, so please do the exercises yourself. Just this is the solution we have now. This time measurement, make it parameterized and repeat the measurement many times and divide the time by the repetition to get a better measurement. You see the time will go down, yeah. And then you can also use a true and false to turn this measurement on and off globally. We did this with this thing, and the last one would be using a class decorator to work with classes. Good. You still?
Maybe we can see if folks have questions.
Yes, we have questions. We have 5 minutes for questions.
Yeah. So you can also add them on Slido. I should be able to see them. If you already added one on Slido and I didn't see it, let me know and just raise your hand. I'm still getting familiar with it. But we have one. What would be some anti-patterns for decorators? So I think you hinted potentially at that with the pure functions, maybe.
Yes, anti-pattern, so the pure function and the class could be one. So whenever you want to change something, then I would prefer, it's my preference, you prefer a class instead of a function. But yeah, let's say, I think recently used cache uses functions and still adds attributes to functions, which could be useful to invalidate the cache. Anti-pattern, so I don't have a really good anti-pattern in mind, but the thing is you shouldn't surprise the user. It should be something that the people expect, whatever this means. Yeah, so don't surprise them and do some side effects that take very long or something like this they don't expect. That's usually something you don't want to do.
Thank you.
Yeah.
Any other questions? Yep, I'm running over to you.
I think I chose a wrong place in Slido. Yeah, anyway, so I wanted to ask when the registration failed because you forgot to add the text, the parameterization, there was no exception raised. So is there some mechanism of hiding exceptions happening, or did something else happen that I didn't understand?
Nothing happened because it still worked. The way I did it, so I have to check because it still returns something and it just calls something and there's no exception. Okay. So you could put it in and say, okay, I want to have, it has to be a text and so on. So so I would need to try this out myself. But you see, it's because it's just a function, takes a function, and it just works and just returned none somewhere. Whatever I did, I'm sure, and it still worked, some function and works. So that can happen. But yesterday we had a testing. Write your test, and they will tell you it's not.
No, I just wanted to ask if there is some additional logic to exception handling happening, but it's not. So
because it's not. It's just did what you wanted to do. It's maybe not what you intended, but it just did what you programmed.
Yeah. Hi. My question is, when would you think about switching to the class and callable pattern instead of just using the wrap function? When do you think, oh, wait, now I need to switch from wrapped to a class in practice?
Yeah, so it's up to you. You can always use classes for everything. You don't have to use the function. So if you don't like this nested thing and you get totally confused, use classes. And the classes, you could have more methods, and you can do a lot of more things with classes than you can do the same with functions, but of course you can always add attributes to function, but the class in instance has attributes already. So it's probably you're more familiar with doing this than adding attributes to functions. So, but all the examples traditionally are always functions that return functions, but you can everything turn into a class, because in the end you just want to have a callable, and how you produce it, it's up to you. So whatever you prefer, when you feel more comfortable, use it. So if you come from function programming, you have no problem using functions to return functions. If you're more procedural, then a class is maybe easier to understand.
Any other questions? Time for one more? Yeah, unfortunately, I don't see them in the Slido app. That's my error. So do you want to read it out? Do you mind? Thank you.
Can you mention a few practical uses of decorators on the typical data analysis science pipeline from Discord?
Especially for data analysis, you can, anything that's cross-cutting concern. So if you want to measure how long things take, then we just did it. This would be maybe something you can analyze your data. Or anything else that you want to do all the time that has nothing to do with your specific problem. That's usually a use case for decorators. So introducing something. So if you use Python and you compile the stuff to Python, then you can use decorators from Python. This would be an example I can think of. Otherwise, data analysis is not that special. It's just programming. So you will have the same programming problem that other people have also, I think.
Thanks for that question in discourse. Hopefully that answered the question. Apologies for my slip up with Slido. That was me, Mike. But I would like to just say huge thanks to you. Maybe folks can come if they have additional questions to the PSV stand.
Yeah. Yes, you come to stand. I can stand around here. You can come to me. I will be at the stand of the Python Software Verband, also sitting there during the breaks at least. Yeah, I also have leaflets here, so if you want to get some of Python Academy, you can pick one up. So you can also contact me. My email is on the PDF. So, and I will also, I've forgotten, I do have solutions. Uploaded the solutions. So you have them. So this is a PDF with all the solutions together, plus the files. So what I showed here. And so please do the exercises first before you do the solutions. Look at the solutions. That's why I'd like to give them after the fact, but we haven't managed to do the exercises yet. Yeah. So.
Thanks, folks. Please join me in a round of applause.
Thank you, Mike.